All right, attempt number 2. There may or may not have been a dog running into this room barking a minute ago and ruining my video, and I don't have editing software. So, what we're looking at in this next section, for this next delta math activity, select the equation from the graph roots. So looking at the important information that we've been going over with roots, because let's face it, your last couple activities have been roots. Okay, this is not nearly as bad as we want to think it is. So, quick version. Things we know about this graph by looking at it. Because which equation choice could represent the graph shown below? Well, equation choice. There's going to be a choice of equations, multiple choice. So we want to eliminate answers. So I'm going to just go things I know. X-intercepts, no problem. X-intercepts are totally easy to find. -1 and 3. I have 2 of them. That's allowed. That's fine. Great. Y-intercepts. There should always be only one y-intercept. That is a -2. And the other thing I know here is that the x in this equation is squared. And the way I know that is actually really simple. Every time you do a graph and your line bends, you're adding 1 to the exponent. So if I had a graph with a straight line, that's a straight line. That's, y equals mx plus b. The exponent's 1. That's it. You're done. If I had y equals x squared, that would be when we draw a parabola a lot like this, except the parabola would actually go through the origin and it'd look better, stuff like that. If you had a y equals x to the third, your line would change direction twice. Again, bad graph, quick scribble just to show you. So if you had a problem where the graph looked dreadful, but you needed to figure out what it went to, I'm going to give you a quick example. Like if you had a graph that looked like this, and you were asked to pick what equation did this graph, what I would look at real quick is every time it bends. The exponent on your x, the degree of the equation, will be the number of bends plus 1. So 1, 2, 3, 4, 5, 6 bends. This equation would have an x to the 7th. So I know that my options require me to have this. So, okay, no big deal. I can work with that. So, I don't need to worry about that right now. But this parabola on the right, it's an x to the 2nd. Boom, done, great. Oh, it's trying to move screens the wrong way. So I have these options down here. So first problem, first option, I'm going to knock it out like that. It's gone. Why? Take a moment, look, think, pause, actually think. Okay, the reason is all these numbers are multiplying. They all have an x. Somewhere these x's will all multiply. That means 3x's multiplying, that's an x to the 3rd. But I said earlier, I have an x squared. Oops, I was apparently on erase, not scribble. So this first option is an x to the 3rd. That's wrong. Second option, 2x's, could be x squared. It's going to be x squared. Cool, I can live with that. A 3 and a -1. That's the same as my intercepts. There might be some validity there. I'm going to keep it for just a second. We'll look at it in a minute. I'm looking for quick, knock-it-out eliminations. Second option, 2x's, x squared, also could be good. -3 and +1. I don't want to throw that out yet, but that is also in the same area. But I don't know, maybe this one's better because it has the +3, just like this intercept, and the -1, just like that intercept. So, who knows? Last option, x, 3 x's, all multiply. I'm going to have an x to the 3rd. So, I know this last option's out. So the question is, which of these 2 options could it be? Here's the thing. We are going by our intercepts, right? We're looking at our x-intercepts, where x equaled 0. And guys, if you remember from the last couple videos and in general, an f of x is basically the same thing as y. So if I want to know what is this when this is a 0, well, I'm going to say 0 equals, because instead of f of x, I'm replacing just entirely with a 0, x plus 3, x minus 1. Okay, guys, you solve it, you do it out. We've done these. This was like the last one in the one before. I would solve this out, and I'd get negative 3 and 1. Are these actually my two intercepts? When y was 0, I got a negative 3 and I got a 1. That's not what I got. Over here, this graph was a 3 and a negative 1. So I need to have that negative 1 and 3. So I'm going to check the other one real quick. If I had 0 and it equals x minus 3, x plus 1. If you guys need, take a minute, solve it, make each one of these equal 0, find the answers. Okay, so I have a 3 and a negative 1. That's the intercepts I need. And I haven't even looked at the y-intercept yet. What is it if x is 0? I'm not too stressed about that at the moment. Honestly, I just want to move on with my life. So, bloop, I'm saying it's that guy. And, wait, there we go. Submit answer. Yes, I want that to be my answer. Huzzah, I'm right. Because I found the roots. I knocked out the options that were not going to be x squared, and then I found the option that gave me those roots. That's it. So, another example problem. It's parabola. Okay. So as I erase the junk from my old problem, you should be keeping what? Gosh, I feel like I'm on Sesame Street. Can you tell me I'm watching that with my kids? What is it, kids? Pause dramatically. Wait. Okay. Yes, x squared, because I have one bend, so we add 1 to our exponent, giving me an exponent of 2. So it's x squared. My intercepts, well, those aren't going to be the same, right? No, they're not the same. All right. X-intercepts are 0, zoom, and 4, zoom. Okay. X squared, or y-intercept, it looks like a 0. But I didn't even use that in the last problem. I'm not going to stress it, but it's just an easy observation to make. Fill it in on MCAS open response under the things I know before I start working heading. Shows that you're paying more attention. Gets the score up, maybe. Just putting it out there. So I've got this. Okay, scrolling down. Alrighty. I have x minus 4, x minus 4. 2 x's, they'll multiply x squared. Okay. X minus 4, they'll multiply, they'll give me x squared. Okay, can't knock that one out. X plus 4, okay. All of these have 2 x's, so that x squared thing doesn't help me knock any of these out. So I need to think about these again. Remember, our f of x is the same as y, so we're going to replace these with zeros. And I want one that will give me, if I say 0 equals, and I write down one of these polynomials, my answer would be 2 different numbers, and one of them is 0, one of them is 4. I can tell you, knowing that it's 2 different numbers, I'm not using either of the top options. If I solve this polynomial, I'm going to get 4. That's cool. I like 4. But I'm only going to get 4. I'm only going to get one option. That's not good enough. I need 2. This one over here, I solve it. I get one option. I'm going to get a negative 4, where my x is a negative 4. A negative 4 is not even an option. My x-intercept is a 4, not a negative 4. And again, that's one answer, not 2. So it has to be one of these. You solve either one. Okay. You can use process elimination. Just pick one and solve it. Okay. X plus 4. All right. I'd go 0 equals x, and 0 equals x plus 4. So I'd get 0 equals x, and negative 4 equals x. Well, hey, That's not right. I need a 4. So I've ruled out this third option. This third option's totally out. So that leaves this guy. If I solve it, I will get 0 as the one on the outside and a plus 4 for the one on the inside. Free pro tip, an x by itself sitting on the outside in a polynomial, that's going to be a 0. So submit answer, that guy, boom, yes, I look good, great. Next problem. All right, 1, 2 bends, that's going to be an x to the third. Cool, changing it up. So erase the junk that I don't need. I know if I was really pro, I'd pause and do this between. Maybe I'll practice that for the next video. Can you tell these are the first videos I've ever made? Probably. They're kind of dreadful. So, things I can tell. First off, this is an x to the third. Just wiggle, wiggle. My x-intercepts are, well, I still have only 2. That's fine. I have a 2 and a 7. Y-intercept hasn't been at all useful in the last couple problems. But again, trying to look good. Pretend it's like a Zencast. 1, 2, 3, 4, 5, 6. It looks like a 7. I'm going with that's a Y-intercept of a 7. But remember, it's down, so it's a -7. Boom. Information I know. So it's got to be one of these 3 options. I'll x to the third. All of these problems feature 3 x's. Okay. Great. X to the third. That doesn't get rid of any of them for me. As you saw in the first example problem, though, it will help sometimes. So you guys take a minute, think about it. With what you've seen for patterns in the last 2 problems, go back if you want. Look in the video. You can pause and start me as much as you want. What are our answers going to be? By now you've paused and gone back, or you've just waited it out. You're going to get 7 and 2. Which can only be produced by the -7s and the -2s. So here, this third option is what I want. You could use a couple little bit factoids for quick elimination. Everything needs to be the same sign because both of these are the same sign. So you could have knocked out these first 2 options using that quick elimination. Submit this answer. Yes, great, good. So 13 minutes. This has gone on way longer than I wanted it to. Probably longer than you wanted it to. Remember, drop-in tutoring, Wednesdays, 1 to 4. That's going to be every week. So even if you're doing this in like 2 or 3 weeks, it's fine. Each week, I will have a second drop-in tutoring session. You will have to check that week's notes for times. You can always call me on my Google Voice number. You leave a message or text me. It's no different than emailing me. I'll check it once or twice a day, weekdays, maybe on the weekend if I have time and or I'm feeling like it. But reach out to me. Snippet, call, whatever. Get in touch with me if you have questions. Drop into the tutoring session if you have questions. You guys should be okay. And for this week, or these 2 weeks of 5.3 or 5.4 and 5.11, you got 1 video left. You're almost there. Come on, guys. I can make it too.